Hi folks, so this question here guys is from the 2018 Ordinary Level paper. It is based on the topic of geologic geometry, otherwise known as road geometry sometimes. Okay, it is from the section C of the paper, C1. So just looking here, we can see the information that's given to us. Okay, so it says section C, question C1, geologic geometry. The accompanying map located on the back page of section A shows ground contours at 5 meter vertical intervals. So this map, guys, is always going to be given to you on the back of section A. And what's important to note there is we have 5 meter vertical intervals, which is very, very important there to us. Okay. So you can see the distance between our contours. You look here, contour here, saying 30, 35, 35. So the distance between them is 5. Now part A, on the drawing supplied, draw a vertical section profile on the line AB. So you can see here we've got a line AB and we have to draw a vertical section profile in the space up here provided. That's essentially where we have, it's like we've taken a slice through the mountain, and where it's cutting through our contours, it'll give us kind of a point here on the kind of mountain's topography. Okay. Now part B, a vertical pylon is to be built at point A. Okay. On the profile, determine the minimum height of the pylon if it's to be visible, or sorry, if its top is to be visible from the ground at point B. And then part C, the image on the right shows a section of the new M17 motorway linking Galway and Clare. Okay, so we can see it here. Earthworks were necessary to accommodate the roadway shown. CD is the centre line of a roadway which is level at an altitude of 25. Using side slopes of 1 and 1 for cuts and 1 and 2 for embankments, otherwise known as fills. Complete the earthworks on the northern side, which are necessary to accommodate. Okay, so we're going to focus on section A and or part A and B first, and then we'll get on to C, which is kind of the roadwork section. Okay, so part A, on the drawing supplied, draw a vertical section profile along the line AB, and then we'll get on to the pylon bit. Okay. So what we have to do first of all, guys, is kind of identify what measurements we're going to go up here. Now the distance between our contours is 5, okay, and they already told us that. And what's important to note over here is our scale. So our scale is 1 is to 1000. So usually on my sheet, I'm just going to use this area for a little bit of rough work. So what that means is 1 millimeter on my sheet, OS, is to 1000 millimeters in reality, IR. Okay, so we want to work up to that. Now what's important to note here is 1000 millimeters. What does that equal to in reality? Well, 1000 millimeters is 1 meter, and we want to essentially work up to 5 meters because that's the distance between our contours. So what do I have to multiply 1 meter to make 5 meters? You have to multiply it by 5. So if I multiply this by 5, which will be 5000 millimeters now, okay, so that's in reality. If I multiply this by 5, I also have to multiply this by 5. So 5 times 1 is 5. So that means 5 millimeters is the distance I'm going to measure up here from my sheet. Okay, so that's kind of how you work that out. Now, along the line AB, I just want to identify the contours. Okay, so my highest seems to be 45 here at B, and my lowest is 10. Okay, so usually a good starting point then is I usually start right here, because if you take this as the plan down here, up here is my elevation. I'm going to measure up in 5 millimeter increments. So measuring up in 5s. So 10, 20, 30, sorry, 10, 15, 20, 25, 30, 35, 40, 45. Okay, project those lines across. Obviously on the day you'll be using a 2H pencil, which is a lot lighter than what I'm obviously using biros here. Just for demonstration purposes, I find it comes up better on the camera. So there we have it, and what I'll do is write in the information. So if that's 5, this will be 15, I'm just going to skip 25, 35, 45, then down to 40, 30, 20, and 10. Now what I want to do is identify where the vertical cutting section, you can kind of see it here by the line here, is going through our contours. So you can see it A here, A is right at 30, so at this point it's quite easy, but just project up to my 30. 35, likewise with the next one, and we're back down to 30, down to 25. So just follow it. Usually only steps down 1, down to 20, down to 15. Then I have 2 10s. So there's 10 and 10. And we can see from here now it's starting to rise again. It's going 15, 20. Just checking out to make sure I'm still accurate. Yes, 25, 30, 35, 40, and finally at B, 45. So that's the highest one there. So you can kind of actually see profile. So I'm going to sketch that in quickly. So there we have part A done, guys. That there is the vertical section profile done along the line AB. Now it said for part B, a vertical pylon is to be built at point A here, so we can see point A right there. Okay, and on the profile, determine the minimum height of the vertical pylon if its top is to be visible from the ground at point B. So essentially, we need to build on a little vertical pylon. Okay, so essentially, it's kind of like a little, if you imagine here, we've got a tower going up there like that, a little pylon, and from B, okay, at ground level, which we know is at 45 meters high, essentially I need to be able to see my line of sight. So what I'm going to do is from B, right here, I'm going to do a line over there like that line of sight there. So as if you imagine someone was standing here and they're looking along it, so that's their line of sight. My pylon is over here, and now I can actually determine the height of the pylon. And I'm saying that, looking at it roughly, if we think it's 5 meters and it's going up 1 millimeter extra, so it's about 6 meters there. Okay, so 6 meters is my height of my pylon. Okay, for it to be visible from point B. Now that's part B done, guys, as well. And now what we're going to do is move on to part C. So for part C and earthworks, what we're always going to have to do is use a little bit of rough work. So CD is the central line of, the image on the right shows a section of the new motorway M17 linking Galway and Clare. Earthworks were necessary to accommodate the roadway as shown. So you can see they've already done on the southern side of the roadway from C to D. So they've all these kind of earthworks already done. Now, CD is central line of the roadway, which is level at an altitude of 25. So the roadway has a constant altitude of 25. So level at 25 meters. Now, it's saying using side slopes of 1 and 1 for cuts. Okay, so I'm going to come down here, and what I'm going to do is I'm going to go my cut ratio. So usually what you have is this kind of cut triangle. Okay, so 1 is to 1. So that means for every 1 meter I drop in vertical height, I'm going to step out from the road 1 meter. So my cut ratio. And what we have to do is we have to apply the distance between our contours. And we know already that to be 5. So 5 times 1 is 5, and 5 times 1 is 5. Okay, so that's our cut ratio. But the one that we really see, remember we're looking in a plan view. Okay, so we can't see the vertical distance down in our plan view, because we can't obviously measure into the road, okay? But what we can do is we can measure out from the road. So for our cut, we're going to use that there, 5. Okay? Now our fill ratio, or what's called actually our embankment, okay, which is what they say up here, embankments. Okay, our ratio for that is 1 is to 2. So our fill ratio, that means, let's see a different kind of triangle here. For every 1 meter I go down, I'm going to travel out from the side of the road 2. And remember, it's the one that we're going out from the road that we can see. So once again, multiply, our magic number is usually what I call it in class. Multiply that by 5, so 5 times 1 is 5. But 5 times 2 is 10. And remember, this is the one that we can see as we look down on top of it. So our number that we're going to use is 10 for our fill. So we just have to identify what portion of the road we're cutting on and what portion of the road we're filling on. Okay? So where the land is higher, we're going to cut away. Where the land is lower, we're going to fill up to it. So we have to identify that. So looking along the contours here, so from C to here, so anywhere the road is actually at 25, okay, and it tells us, just make sure, 25 meters. Yep. So you can see here 25 is cutting through it. So that's going to be an intersection point right there. Okay, where the level of the land is the same as the road. Is there any other 25s? Yes, I got another one here. I can actually use the ones that are previously here. So there's my 2. So in the sections in between from here to here, I have to decide whether it's going to be fill or cut. Likewise with here, and then from here as well, onwards. So looking at this section from here to this kind of intersection point here, looking at the contours above here, I can see that they are 30, 35, 35, 30. They are all higher than the level of my road. So because they are higher than the level of the road, that means I'm going to cut. And we know our cut ratio then is 5. So measuring out from the side of the road, I'm going to measure out 5. I'm just looking there, 25, 30. I actually only need 2, I think, because I already have, yeah, that's it. So from there, I'm going to measure out there like that. This is how I usually do it. So if the road is at 25, technically 25 is right here on the side of the road. Then the next one up is going to be 30, because we're going up in height when we're cutting. Okay, so at the 30 I can see where it's passing through the 30 contour right here. And then it's also passing through the 30 contour here. And likewise 35, 35. Okay, so you can see it there. Now what that would appear then is, sketch it in as quickly as I can. Okay, so that there is the cut section of the road, and if you want, write in cut there. Okay, so we knew that that section there was cut. Now from here to here is important. Okay, so let's identify it. So at this point here is 25. Now what do we notice about the contours in this section? They are all lower until they go from 25 to 25. So because they are lower, we're going to apply our fill ratio, and we worked out our fill ratio to be 10. So if the road is 25, we're going to measure out 10. So that'll be 20, 10, so 20, 15, 10. Perfect, that should do it. So the first one out will be 20 and 20, so there to there. And the next one is going to be the 15s and 10s. So you'll see here, road is at 25, this here is 20, so we're going out from the side of the road. Remember, this is 25, this line, but when we're doing fill, we're going to drop, okay, in height from outside, from the side of the road. Then these ones are going to be 15 and then 10. So at the 20, I can see cuts through the 20 contour there, and also through the 20 contour here. Likewise with the 15, right here, and then 10. So same concept then. So there we have it, and once again I'm going to write fill in there. And the next section of the road we just have to identify. So we have 25 here. I can see this contour is 30, 35, 40, 45, 55 or 50 again, then 45, 40, 35. So you can see it's kind of going down before it goes up again. So all of this is actually higher than the road. So because it's higher, all of this section here is actually going to be a cut. So I can use my same contours, but obviously I can see that they go up a little bit higher. This time goes up as far as 50. So I'm going to measure here from the right hand side of my road this thing. So 5, so that'll be 30, 35, 40, 45, 50. So 30 there, I can actually see it's cutting right there. So you can see I'll just keep it a bit neater this time. So just to show you there, that's 25, 30, 35, 40, 45, and 50. So I can actually just put it through my contours. Was there any 30? No. So the next one is 35. So you can see here I've got this one, and this one. Then the next one is 40. So I've got 40 there, got 40 here, and 40 here. The next one is 45, So I've got my 45 here, 45, and then finally I have my 50. So there's 50, 50. I think that's it. So there we have it. And just looking here. Oh, missed 145, apologies. Right there. So it's going back up at that point. So you can see here all kind of my intersection points, so sketch that in. So there you have it, guys. There is the earthworks completed for the part C, okay, where we did our cut. We applied our cut ratio and our fill ratio, otherwise known as the embankment ratio, to do the northern side of the road. The southern side is already completed. Now usually when you get this done, guys, what we would always usually do, just to finish off this kind of earthworks, okay, is that you would identify on the kind of map, okay, whether it's a cut or a fill. Now what you can see here, I've already written in cut, and fill was this section, then cut was here. But usually what you use is this method called tadpoling. And tadpoling is essentially, if you imagine a ball was at the side of the road or on the top of the hill, depending on if you're cutting or filling, and what direction that ball would run. So when it's a cut, the ball usually rolls towards the road because the land around it is higher. Okay, so I put a ball there and a ball there, and look, just identifying the opposite side, and that ball will roll towards the road. And they call it tadpoling is because we just kind of put in, looks like little tadpoles. In the case of fill, the road is higher than the land on it, so we put the ball at the side of the road, and the ball rolls away from the road. My tadpoling technique has never been the best. And then once again cut, so pop a few balls up on the kind of higher parts of the road, likewise on the opposite side, and they will all roll towards the road. Nice and easy. Okay, there we have it. That there, guys, is the earthworks necessary for that portion of the road. Okay, that there, guys, was the 2018 ordinary level question. Hope you found that helpful. That's that done.